Welcome. Thank you for attending. The session is recorded, so if anyone is willing to, we can review it later. This is the part 2 of introduction to Stata. During the part 1, we looked at this simple adding the data, looking at the variables, looking through the summary statistics. Now we gonna continue with some of it plus some basic analysis. Okay? So what we usually do, and just to remind you, this is the Stata display, how it usually looks like. On the right-hand side, you have variables here. You write comments here. Here, for example, if you say clear, it clears all the data and everything. On the left-hand side, you can see a list of all the comments in there. Okay. So first thing we do, we go to the do file, because do file is your kind of working area, like a sandbox. So I already have a do file prepared, so I'm just going to open one here. So in the do file, all the green areas are just a simple text. And that's why if you put a star, these are for the nodes. And whenever you run the do file, it doesn't run these, it just recognizes as just nodes for yourself, okay? So, for example, the do file is basically a list of all the things that you want to run from top to bottom. I can press this run button here, or it says execute, or Control D, and it's gonna run from all the way from the top, all the way to the down. So it's basically imagine you have a project like a paper, you start with data cleaning, then you generate the variables, then you analyze things, then you generate the tables. You can write all of it here and it's all saved. So you don't have to write it every time. So do file is your basically all the things that you're planning to do. So you complete the do file along the go, you add more stuff, until this is your like final work. And then if someone wants to replicate your analysis, you just give them the do file, which shows exactly what you did, which comments you ran, how you clean the data, and so on. Okay, you can add notes here, like you can say the purpose, the note, what are you doing, the step number 1, import the Excel file, and so on. So do file is very useful in that sense. If you want to run specific commands, you can do that as well. Like you mark whatever the comments you want, and then you press Control Do, and it just does only those comments. Okay, so it's very easy to execute. So I'm just going to clear the whole thing. And top to bottom. So you may recognize here the first line CD and then the path to the folder where you're working on is an easy way to, it's called change directory, CD change directory. So one useful thing to do is that you assign Stata a specific folder you're working on. So when you save something, when you want to use certain files, it just goes directly to that folder, okay? Otherwise, for every file, for every saving, you have to write the whole path of the whole folder every time. So for example, I say here, change directory to, I specify the folder I'm working on, and I'm pretty sure you know how to get there. You just go to the top and then you get there. Clear all just means delete like all the variables, clean the whole display. Set more off, I mean, this is just an, more like a, how they say, habit, because back then when the Stata had limited number of workspace, you like run something and it's very long, and then it stops until you press more. So it's kind of, you tell it to continue. But now the Stata is quite powerful, and for even for long code, it works pretty well. But this is just like a habit. Don't ask me to press more. Just set more off. Like just continue running the code even if it's long. So that's the easy part. So last time I showed you how I copy pasted the data. So I went to the Excel file. It's here. So one easy way to just copy paste the data, you take it, whatever data you need, you go to Stata, go to the data editor on the top, and then you just paste it. And it's asking you, is the first row variable names or the data? You say variable names. So here it copy pasted the region, year, GDP, unemployment, and inflation. So last time we said that if it's a red color, it sees it as a string variable, meaning it's like a text. If it's a black color, then it sees it as a number. So year and GDP, it sees it as a number. Region, it's a text, so there's no issue there. Unemployment and inflation, on the other hand, it's seeing it as a text for some reason. And that's because of those dots. In Stata is US based, so they use dots for the decimals. Unlike here, we use, in the Russian system, we use this commas, right? So that's why it sees commas as a text, so it doesn't recognize it. So you can work around it. You can, what I used to do, I go here and change these all commas, if possible, like I mark here, and then say change, replace commas with dots, but I'm pretty sure it's gonna mess it up. So then it recognizes it as a date, which creates a mess. I remember this times, it's just a little messy. So another option is to just directly get the data through the do file. I mean, through the command. So let me clear it first. So one thing you can do, you write a comment. I can mark this and press Control Do, then it does it for me. Or you can write this comment in this comment area, and it's going to look like this. Import, you specify the file type, Excel or CSV and so on. Then you write the name of the file, and you don't have to tell it which folder because you already declared it before, right? In the previous, like CD here, change directory, you declared it to work on this folder. So it's going to look for a file called Kazakhstan region stata.xlsx, and then you specify which sheet you're working on, and I think the sheet was called data, because Excel can have multiple sheets, so you need to tell which particular sheet. Sheet is called data, and where is it? First row, meaning that the first row is the variable names. And clear is just clears everything what was before. Whatever the data you had there, it clears it. If you had some data already there on the working area, and then you then say clear, it's going to tell you where I'm going to import it. You're working on something. Do you want to save it? So if you say clear, it just automatically clears everything else. So if you do this, and then go to the data editor, you can see now it fixed it. It kind of fixes automatically this issue. Now unemployment and inflation are black color, which means it recognizes it as a number, as it should. Region is of course still red because it's all text here. Okay. So now on the right-hand side, you have the list of variables: region, year, GDP, unemployment, inflation. You can rename them, and Stata makes it so much easier. To be honest, unlike R, I don't know, maybe not the final part. So you just say rename region to oblast. That's it. It's renamed. You can say label variable or var oblast, and then you can add whatever you want. 17 oblasts and 3 cities. And it adds a label here on the right-hand side, as you can see. So it's easy when you're cleaning the data. You know it's oblast, but for others, some of the abbreviations might be a little confusing, right? So for example, yeah, we know it's unemployment, but you can say label variable unemployment, and you can specify unemployment and then specify the scale, percentage. Okay? And then it adds a label here next to it. GDP, for example, there are many types of GDP. You can say label var GDP. GDP, it's not per capita, it's just general. And you can say, I guess, nominal. Okay? If it's nominal, you can just leave this. If it's real, you specify 2010 prices. So it's adjusted from 2010 prices and became as a real GDP. So I believe this one is nominal, so I'm just going to keep nominal. Okay. So whoever looks at your data understands what kind of variables are those. Okay. So I'm going to rename, or actually, I can come back to it. So then you can look into your variables. For example, I want to see what kind of oblast I have. So I say tabulate oblast. It's going to give me a list of all oblasts and how many observations I have for each oblast, right? Since there are 11 years, there are 11 observations for each. Then I can look at tabulate year. It's going to give me all the values that there is in the variable year. So there are 20 oblasts and cities. So I have 20 observations for each of the years. Okay. Technically, you can do it for others too. What if we tabulate GDP? It's going to give me all the unique values of GDP across all oblasts and years. So it's going to look like quite long. As you can see, it's like all the different values that GDP has. Okay. Sometimes it's useful if you want to see a specific outlier, but for numbers, we just use sum. And it's going to tell you how many observations you have, what's the average, what's the standard deviation, and minimum and maximum. Okay. Or you can say sum GDP D, which is detailed. And it's going to give you percentiles, variance, skewness, kurtosis. It's going to give you 4 largest values, 4 smallest values, just to get you a little better idea. Okay. You can summarize GDP, unemployment, and inflation like this. So it's going to create a table like this. And this is what we report usually when we do a paper, right? For each variable that we use in our analysis, we report a table like this to show how many observations we have. As you can see, for inflation, for GDP, we have 220 values. For unemployment, we have 210. So there are 10 missing values for unemployment. For inflation, we have 218. So we have 2 missing values for inflation, right? So it gives you this good idea of how your data looks like. Okay. Sometimes you can, well, I don't. You can, by the way, you can have cross tabulations. So you can tabulate oblast and year. It's going to give you probably not the most meaningful, but for each oblast and each year it's going to give you show a table of how many observations you have, something like that. Okay. Sometimes it's useful to check, but we don't have that many variables here, so but this is an option too. It just gives you the table of these two values, all oblasts on the left side and all years on the top side, and it's going to give you how many observations are there for each. Okay. Another thing that I frequently use is tabstat. So table of statistics, or tabulation of statistics. I say, give me a tabstat of GDP, and I can specify, which is very useful, by oblast. Then I specify which statistics I want: mean, standard deviation, minimum, and maximum. So if I do this, it's going to give me for each oblast across years, what's the average GDP, standard deviation, minimum, and maximum. Okay, so I can see within each oblast. Or if I press Control Page Up, it's going to bring me the previous comment. So instead of oblasts, I say do it by years. So it's going to give me for each year across oblasts, what's the average? So this gives me a trend, for example, right? So this gives me a trend of GDP, nominal GDP. By the way, it's probably millions or maybe even billions of tenge. That's another thing you can specify in your label there, because readers might be interested in that. So this gives you a good idea about your data and so on. So you can do this for unemployment, inflation. So I like it how it basically gives you a good idea of how your data looks like. Okay. So coming to let's start with this. Let's do a very simple Euler's regression. Okay. To do Euler's regression, I can copy paste from the do file, or I can just do here. I say regress GDP on unemployment and inflation. That's it. Okay. If I press this, it gives me a table that looks like this. It's going to give me some information about number of observations here, the F statistic, the F p-value, R squared, adjusted R squared, the root MSE. You have the residual sum of squares, the total sum of squares. So it gives you the basic information about whatever you're looking at in the Euler's regression. And then you have variables here. So unemployment, it gives you the coefficient, standard error, the t statistics, and the p-value. So by looking at this p-value, we judge whether it's statistically significant or not. Okay, if the p-value is less than, it's up to you which threshold you use. Most common one is 0.05. So we see that it's right at the edge of that, right? For example, for inflation is statistically significant because it's the p-value is 0.05, which is right where the threshold is. On the other hand, unemployment is not statistically significant because the p-value is very high, way above 0.05. So that's why it's not the best idea to look at the signs whenever it's statistically insignificant, because you can see the confidence interval includes 0, meaning that it might as well be 0. So we don't know that. So coefficient is not that meaningful. For inflation, on the other hand, now we can interpret. We can say when inflation increases by 1%, the nominal GDP increases by 161 million tenge or something like that. Okay, depending on how we measure it. So now you can do the interpretation. So I'm not going to focus on that too much. What I care here is to test for some of the assumptions. Okay, I'll go with the simpler version. heteroscedasticity and multicollinearity. For more serious ones, obviously, we don't have enough time. So to test Bruce-Pagan test of heteroscedasticity, you say, basically you run this command, a stat het test, heterogeneity test. So it gives you this type of results. What you look at is this p-value. So the p-value is 0.01, and as long as p-value is above 0.05, we fail to reject null hypothesis. And the null hypothesis is that there is evidence of heteroscedasticity. So as long as our p-value is high, more than 0.05, we're fine. There is no heteroscedasticity. If the p-value is very low, then it's an evidence of heteroscedasticity, which means your standard errors might be biased. You have to do something about it. So one easy thing to do is just introduce robust standard errors. I mean, it went with VC robust because it's a panel data. But if you're working with cross-section data, you just say just robust. That's it. You can just do something like this. So if you have light heterogeneity, once you run this regress GDP on unemployment inflation, you can add in the end robust, and it fixes heterogeneity, not systematic ones. It went to the level that basically most of the times robust is like a standard thing we add in the end, just to fix any light heterogeneity. So if you run it with the robust, again, you can see results. It didn't change much, basically the same numbers here, as you can see. The reason why the numbers are same is because we didn't have an issue with heterogeneity. So you can see compared to the previous one, nothing much changes actually. So standard errors increase very slightly, but the coefficient doesn't change. Okay. So the next one is to look for multicollinearity. So multicollinearity, first you run the regression again, and then just say VIF. It's variance inflation factor. If you just run VIF, it gives you VIF coefficient for each independent variable. And as you may know, if the VIF is low, then there is no issue of multicollinearity. If it's 5, it's concern. If more than 10, then it's a serious concern. So you have to do something about it. Maybe drop one of the variables or something like that. Okay. And the last test, very simple one, is also test of specification, misspecification. So it's called the Ramsey reset test. It tests for omitted variables or wrong functional form. So it's also a good kind of evidence whether we should see if there is something that should be squared. Maybe the impact of inflation is not linear, maybe it's quadratic. So it gives you an idea about that. When we run this, the null hypothesis is fail to reject the null hypothesis. Where's the null? Yeah, the null hypothesis is that there is misspecification, meaning that you want this p-value to be high, then you reject that it's misspecified and there are issues. So yeah, H0 model has no omitted variables. If you reject it at very high level, then it has omitted variables, right? Does make sense? So if the H null is, as you can see here, model has no omitted variables. If you reject it, then the model has omitted variables. So it's kind of misspecified. So in this case, we barely at the edge, so we fail to reject if we're using 0.05 threshold. and we reject it if we're using 10% threshold. So we're like, there's some misspecification possibility there. So looking at this, you can go ahead and try a quadratic form, interaction effect, or maybe try a log, taking the log of some of the, maybe instead of, yeah, let's try that. So for example, I see that there is some evidence of misspecification. So how about instead of using GDP, maybe I can use log GDP. So what I do, I generate a new variable. I call it log GDP, okay? And then I specify the function. I say take the log of GDP, this. It generates a new variable called log GDP, which is the log of the GDP variable. So now instead of regressing reg GDP on inflation and unemployment like this, I run regression of log GDP. If we're taking the log, inflation becomes kind of insignificant. Okay, and then I can again run the OV test here to see if it's still misspecified. Well, it got better. Okay, so it used to be 0.05, like here, close to 0.05. Now we're less likely to reject the null hypothesis. So it seems like it's a slightly better specification to use the log of GDP rather than the GDP as a linear function. I can further try and see maybe the square of inflation matters. How can I generate the square of inflation? I have inflation here, right? I can say generate inflation, and I can say skew, like a square, equal to, I can just say inflation times inflation. So it's basically the square, right? So if I do this, it's going to generate a new variable, which is the square of the inflation. So what I can do, I can say run the OLS with log of GDP, inflation square, and unemployment. Okay, I can also add robust just in case. If I do this, well, nothing is significant. So this is an evidence that inflation doesn't have a quadratic effect, right? Like there's no quadratic impact like that. So might as well drop. I can try that with unemployment as well. I can generate, or I can generate like inflation, unemployment, direction variable. I guess no, IV doesn't make sense because it's instrumental. And that it's just a name. So I can generate a new variable, which is a multiplication of inflation and unemployment, which is an interaction effect. So I can say inflation times unemployment, and it's going to generate a new variable, which is a multiplication. So now I can run the regression. I skip square because it doesn't have an effect. And then if I press on this, it's going to add this new variable. And I can see if there is an interaction effect of inflation and unemployment. The coefficient is insignificant, so it seems like there is none. Okay. I believe there is another way to do that without generating a new variable. If I see inflation, unemployment, factors may not contain non-integer values. Doesn't matter. I remember there was inflation. Yeah, it doesn't matter. There was another like a shortcut there, but I forgot. So this is a simple OLS. You do your basic OLS, you try different functional forms, you try interaction effect, quadratic forms, you test for some of the assumptions like homoscedasticity, the multicollinearity. So you have this very easy way to manipulate the variables, generate new variables. As you can see, if we go back to the data editor, you can see these new variables generated, right? This is the log that we generated from GDP. This is inflation squared, which is the square of this inflation variable. This is inflation times unemployment, which is kind of interaction effect. And you can see like new variables are added. You can check the values, make sure that the multiplications are meaningful. As you can see, like since unemployment was missing here, unemployment times inflation, which is non-missing, still generates missing value because there's nothing to multiply with. You have to be careful between zero values and missing values. Zero is a meaningful number. Missing, you just don't have data for it. Okay. So since we have a panel data, we can do panel regressions. It's another, in my opinion, kind of a simple extension. But before you do that, first of all, you need to have a numbered code for your oblasts. Right now, our oblast, by the way, I just write ed, like an editor, and it gives me this table with the data. As you can see, it's still red, meaning that it's a text variable. So I need to generate the same, but in numerical values. Like instead of Almaty Oblast, it's going to be 1, Astana is going to be 2, Chimkent will be 3, and so on. So one easy way to do that is to write this encode comment. So if I run this, Control D, I changed the name, so now it's Oblast. Let's call it, yeah, so we can use it. So encode Oblast and generate a new variable called region ID. So if I run this, it's successful. Now it generated a new variable. If I go to the editor, you can see it here. You see region ID and Oblast. The names are the same, but here the value is Almaty city, but here the value is 4. So it assigns a specific number for each of the unique names in the oblasts, okay? So for example, and it does it automatically by applying the label for the values. So for example, if I tabulate oblast, you can see which oblast we have. If I tabulate region ID, you have basically the same thing. But if I say, give me the list of region IDs with no label, null, it gives me the numbers. So each oblast has its corresponding number, okay? And we need it because before we do the analysis on the panel data, we need to specify to Stata which is the nature of the panel data, which are the entities and which are the periods, okay? Because in one data, you might have oblasts, rayons, right? And then years, and then on top of years, you may have months. So you need to specify to state there. I say xt set, which is xt is like a for the panel. If you remember, I mean, in notifications, like when we write an equation for the panel data, we say IT. I for each of the oblasts, T for each of the years. Here it uses XT for that. So we set a panel data where region ID is the subject, and a year is the periods, time periods. So if I do this, it shows me panel variable, region ID, strongly balanced, meaning that we don't have too many missing values. Time variable is years, goes from 2015 to 2025. Okay, so once we declare it, it's easy to describe, it's just describing this data in a little more details. So now I can run panel regressions. And it's very easy. Instead of reg, you say xtreg. And in the end, you just add FE as an option. Okay? So if I run this, it gives me new results. Here, the story is different, right? Both unemployment and inflation are highly significant because the p-values are way below 0.05. So controlling for unobserved oblast-specific characteristics that are time invariant, so controlling for oblasts and time periods, unemployment and inflation do have a strong impact on GDP, nominal GDP, okay? Inflation has a positive impact and unemployment has a negative impact on nominal GDP, okay? If you remember, in panel data methods, there are two methods, fixed effect and random effect. If those unobserved characteristics, region-specific, oblast-specific, something different about those oblasts, right? Maybe culture, politics, maybe some tribal culture or something like that. If all those things are likely to be correlated with your inflation and unemployment, which are independent variables, fixed effect makes sense. If they're likely to be uncorrelated, random effect makes sense. So I store this estimate store is just remembering saving the results of FE. So if I'm not completely sure about it and I don't have a strong argument, I can just run the random effect. All that there is changes, instead of FE, you write RE. FE for a fixed effect, RE for random effect. And then when I run the random effect, I basically have very similar results, right? Basically almost identical results. So I store the random effect. So sometimes you can have a very strong argument for fixed effect, saying, no, I know, there's a lot of evidence in the literature that this type of some factors that are common for regions are indeed correlated with inflation and unemployment. So I'm going to stick with fixed effect. Or vice versa, you say that those are not correlated, so I'm going to stick with random effect. Okay. One of the potentially deciding factor can be in fixed effect, we are demeaning variables. So everything that is fixed over time will be dropped. So for example, if something for all these 11 years, you have a variable on oblast level, I don't know, something like what doesn't change over time. I was going to say ruling party, but all oblasts have the same ruling party. So let's say we define the variable that's called the most dominant industry in that oblast, right? So it's equal to 1 if it's oil, equal to 2 if it's manufacturing or something like that. So if you look at some of the, like over the last 11 years, that probably didn't change much, right? Because for the Atrao, it's still dominant industry, the oil. For Almaty, the still most dominant is still services or manufacturing. So if your variable in your data is that, you need that variable, which was the indicator that shows the dominant industry over time. If you run fixed effect, that variable will be automatically dropped because it's time invariant. Okay? So if you're doing panel data analysis, if any of your variables that you're using in your model are time invariant, they don't change over time, it's going to be dropped. But for random effect, it doesn't drop it because random effect doesn't demean the variables. Okay? So if you have any important time invariant variable, you should use random effect. And that's what I did in one of my research for dissertation. One of my main variables was geographical factor, like area. Area doesn't change much. During the last, well, there are some changes, like some oblasts split into two or something like that. And but for most of the oblasts, the specific area of how many square kilometers that region is didn't change. So for me, using a fixed effect, it's just going to drop the variable. So it's not ideal for me. So if you can use both fixed effect and random effect, what we do, we can run this, what we call Hausman's test, to see if random effect is consistent. The null hypothesis is that RE is appropriate and differences between FE and RE are not systematic. And the alternative is fixed effect is preferred. Okay, so if you run Hausman test and I saved FE and RE as the estimates, it's going to give you this result. And based on this p-value, you can say you fail to reject the null hypothesis, meaning that fail to reject is basically accepting, right? Which means RE is appropriate and fixed effect and RE coefficients are not systematically different, okay? So in this case, it doesn't really matter which one you use. Both of them are kind of systematically the same. And you can see that from the coefficients as well, they're practically the same. Okay. So of course, it can get more complicated depending on what type of topic you use. You have extra tests that you can perform and so on. But at the end of the day, I mean, once you start on this, then you can kind of continue making it more complicated, do robustness checks. But this is the basic kind of explanation of how you work on Stata. Okay. So to be honest, for me, Stata, maybe I started from Stata, so it's easy for me, but it's much more user-friendly. You just say Stata what to do, right? Regress, generate, tabulate, summarize. So it's much more user-friendly. And just to reiterate the point that I made in the very beginning, the reason why R and Stata are so popular compared to other programs, Python is there too, but Python is for those who are comfortable with IT in general. But for those who do data analysis, it's most of the popular ones are R and Stata. The reason why they are popular is because whenever there is a new econometric methodology, the users generate the packages. Okay? Especially it's true for R. Like R, it's free. No, there is no corporation that regulates or like some scientists, data scientists or economists came up with a new methodology and or somebody else developed the theoretical part of it and some others, they develop a package which is a list of comments, but all you see is one line. Okay? So when you say reg, which is regression, right? It does OLS regression. And if you remember from OLS, it's you do some algebraic calculations, right? If you have a matrix or bigger, like more than one independent variable, you're doing manipulations with matrices. All one matrix 1 is multiplied by matrix 2, and then it's squared, and then you divide it, and all in the end you get just one number for the coefficients, right? So when you press reg, in the background, many other comments are run automatically. Okay, so regression is like a package. It's just like a one line to describe everything else that's happening in the background. Okay. The same with xtreg. There's a lot of statistical things happening in the background, but you don't see them. You just say xtreg, and those happen automatically in the background. Okay, so these new comments are generated by users, not the corporations. R, it's true because there is no corporation, but for Stata, even though there is a corporation, it's not free, it's fairly expensive, but a lot of the things are generated by users themselves. So that helps. So it's like Apple and Android, right? It's not like Apple and Android are generating new apps, right? It's the developers, whoever dealing with software, users, all those people who generate the apps, not those who provide the platform. So for that purpose, these two are dominating. R is free, so technically you can just use R Studio and get something similar, but still a little kind of less user friendly. But Stata is, in my opinion, is much more user friendly. It gives you a much better, in my opinion, much better way of viewing your data, not visualizing, understanding your data. By using summary, tab stat, all those things, it gives you a very good idea how your data looks like. Okay? You can go to the data editor, you can see what's happening there. So it's very, for me, it's very easy to use data for those purposes. Some say R is good for visualization, but again, I didn't work on R for that. So fortunately for some, and you guys are aware, whoever is listening online, we're both Stata licensed for this whole year. So if you really need Stata, if you want to learn Stata more, we have it. We're going to have it on the computer here. So you can write an email, set up the time, go play with Stata in there, try different kind of data analysis and data cleaning. So you have an opportunity like that. Yeah. Then that's it. Thank you girls for joining. So I don't have to talk to the voice. They can imagine a person listening to me, but it's recorded, so you can review everything later if you need to. Okay. But сол жағынан оңалады да стата сөздер мен кодинг сияқты Pythonға қарағанда R-ға қарағанда бірақ біз лицензия сатып алдық 1 жылға компьютерімізде бар осында керек болса имейл жазып Science Departmentке немесе маған келіп отырып статада жұмыс істеуге мүмкіндік бар. Yeah. Thank you. Someone.